Oh, hi. I'd like to spend a moment talking about oxidation numbers, or what we might trivially call charges. I made a little list of the commons, carbon, hydrogen, and oxygen, and their oxidation numbers. Oxygen, except in peroxides, which I'll point out in a moment, always has an oxidation number of -2. Hydrogen always has an oxidation number of +1 for us, and we're not sure what the oxidation number on carbon is. Carbon changes its oxidation number readily, and it all depends on its environment. For example, I went ahead and drew two structures up on the right board, simply carbon dioxide and formaldehyde. What we've got going in carbon dioxide is, at the top here, we go ahead and we identify the oxidation numbers on all atoms except for carbon. So oxygen is -2. Oxygen on the right is -2. Now carbon dioxide has no charge, it's a molecule. We don't see like CO2 written out with 5- or 2+, it's neutral. And so by default, the carbon in the center has to be +4. I say that because we're using deduction, going -2 and -2 and +4 all add up to 0. Go ahead and try formaldehyde, COH2 down here on the bottom. Go ahead and assign oxidation numbers to the hydrogens and the oxygen, and then see what you come up with for the carbon. I'm going to put +1 and +1 for the two hydrogens. I'm going to go ahead and put -2 for the oxygen. And what does the carbon have to be? It has to be 0, because we have +2 and -2 I already identified, so the carbon has to be 0. And I like this because carbon is +4 in this molecule, carbon is 0 in this one. I mentioned earlier that oxygen carries an oxidation number of -2, and that's wonderful. It's always the case for us, except there is this very rare exception, and that is in peroxides, when we find that oxygen has a single bond to a neighboring oxygen. What's going to end up happening here is each of the hydrogens is going to be +1. Each of the oxygens are forced to be -1. And that is an exception, and peroxides are extremely unstable.